Welcome back to Mr. Rickland's virtual classroom, where today what we're going to be discussing is we're going to be taking a look at the last lesson in our unit, lesson 5, and it's called Special Triangles. And so to date, what we've been talking about mainly is we've been looking at right-angled triangles. Pythagoras' theorem deals with more right-angled triangles, um, and that's the easiest to work with. Because it's pretty simple where the hypotenuse is, because when you see the right angle symbol, then you know the hypotenuse is opposite of it. But today what we're going to do is we're going to kind of move into a different type of triangle, and we're going to move into more equilateral slash non-right angled triangles. If you take a look here, I've drawn out an equilateral triangle, 60 degrees on each angle. And in order to use Pythagoras' theorem on how to find the area of an equilateral triangle, because that's what we were doing, is we were finding the area and the length of right angled triangles. So what we need to be able to do is we need to be able to take a line and run it straight down the triangle or diagonally, whatever is going to give us right angles. Okay, so when we bisect this straight line here with another straight line, it is going to give us right angles. And then all of a sudden, what you notice is you have start having your hypotenuse, okay, which is your longest side. And so what I want us to take a look at then is I want us to be able to find the height now of the triangle. So it kind of shifts. I mean, we're still finding the length of a side, and we're still using the hypotenuse, and we're still using one of the legs. Okay, and so when we use the hypotenuse and one of the legs, that means we're going to need to subtract. Okay, because our equation to date has been c squared equals a squared plus b squared. That's been our equation. So hypotenuse, leg 1, leg 2, right? So because what we can still do is we can still take our triangle and we can still do a square in order to find what this would be, because each one of these sides we can do a square off of. Okay, and what we do is to find the length then is what we do. We kind of do the square root of the area. So, as Virgin Hill would say, we need to root it, right? So c squared equals a squared plus b squared. So I have my hypotenuse, which is c, 8 centimeters. A, we don't know, that's our height. B, 4 centimeters. Okay, you can switch A and B, it's fine. But we're going to find for A. We're solving for A. So we put our numbers in that we know. We know C was 8, so 8 squared equals A squared, which we don't know, plus 4 squared because B was 4. All right, so when we do that, 8 times 8, 64. A squared plus 16, because 4 times 4 is 16. So I need to isolate now. So I need to isolate A, okay, or A squared is what I need to do. So I need to get A squared by itself somehow. How I do that is by subtracting 16 from both sides. So if I do 64 centimeters squared minus 16 centimeters squared, that's going to equal A squared plus, I'm going to use a black pen here, 16 centimeters squared minus 16 centimeters squared. So when I have the 16 minus 16, that just cancels out. That's 0. So then what I do is if I subtract these two numbers right here, I get 48 centimeters squared equals a squared. Now, here's the deal. That's the area. So I know what the area of h is, but I don't know what the side length is. Well, in order to find the length, remember length equals square root of the area. So let's do that. So length, or h, equals the square root of 48. So then h equals square root of 48 is, just 1 second. You could also use just the square root of 48, but let's see here. 48 square root should give us 6.9. So h then equals 6.9 centimeters. Now that's going to be important as we go along because we're going to run into some problems where you're just going to have to really think about the question that you are doing, and you're just going to have to think about, how to solve this question and how to approach it, especially when you're only given one of the sides. But if you take a look at the markers, there's usually always something in there that indicates how to go about solving this problem. Okay? And if you keep in mind that the hypotenuse, the area, has to be the total of the other two areas, if you keep those things in mind, those problem solving questions will not be that difficult. Okay? But you got to keep those things in mind. You got to look for the markers, and you got to keep in mind that the area of the legs equals the area of the hypotenuse when you add them together. Okay? Your practice is 354, 353, and 354, questions 1 to 3 and 7. And then we're going to be doing some review.